Hi, so in this video we are going to talk about a new design pattern called as the Decorator design pattern. Now, just like all my videos, this video format will also be in three parts. The first part we're going to talk about the reason or the motivation to learn this new design pattern. Second, we'll see what it is exactly, and third would be how we are going to implement this in Go. Now, before starting in design pattern, I always ask this question: what is the need for learning a new design pattern when we already have other design patterns? So what makes this design pattern so special, right? Or yeah, I can also say that why should I even learn this in the first place? So let's see an example here, and let's try to understand how this design pattern comes into picture and how does it helps us in solving such a complex problem. All right. Okay. Now on the screen, if you can see, I have created this class diagram. Okay, so the question here is, let's say that you're designing a notification system, right? Now a notification system can have multiple channels over which it can notify you for some message, right? For example, it can notify you using SMS, or it could be on a social media platform. It could be Twitter, it could be Facebook, or any other platform, right? It could also be a Slack channel. Okay, just for sake of simplicity, there are only three channels mentioned here, but you can imagine, right? You can imagine that you can extend it to any number of channels. Now if you see here in this diagram, all these three classes are basically mimicking those three different channels, right? So if you want to notify a user over a Slack channel, you will basically use the object of Slack notifier, right? And similarly for the other two notifier also. But now the problem becomes interesting if the user wants to have a mix and match of all these channels. And in a real world scenario, it's not it's very unlikely that a user will have notification on one of these channels. It's very common to happen that a user might want notifications to happen parallelly at multiple channels, right? So let's say the user demands that he should have a notification for Slack as well as SMS. Okay, and let's say if it's a critical bug, then it should be notified on all the channels, right? So here is an extended diagram to this. Now here if you see here, we have combinations of different channels. For example, we have SMS plus Facebook notifier, right? So a user can opt for such notification. So essentially he will get both SMS and Facebook notification, right? We already have the three ones. We already have the three notification system, which is SMS, Facebook, and Slack. But apart from these three, we also have a combination of these two. Oh, sorry, a combination of these three, right? So we have SMS and Slack, we have SMS, Facebook, and Slack, and then we have Facebook and Slack, right? And then in the end, we can have a combination of all the three. Okay. Okay, I think that's already covered here. We're having a combination of all three. So if you look at this, this becomes more or less like a combinatorial problem, right? Because if the number of channels increases, let's say in the future, let's say if I add email notification, or let's say I add I add a real-time monitoring system also to this notifier class, then I'll have multiple channels. And now if you see this is a combinatorial issue, right? Because now I can have n cross n minus 1 combinations here. So if I try to calculate this becomes like an n factorial problem where every channel will have a combination with the rest of the n minus 1 channels, right? So essentially this is an n factorial in nature. So because the first channel can communicate over n minus 1 channels, then for the rest of the n minus 2 channels it can communicate with n minus 3 channel, and so on and so forth, right? So if you see here, this is essentially nothing but n factorial in nature, right? Therefore, if I take the approach of creating subclasses, right, because that's the very first natural approach to solve this problem, right? That is, we'll have a notifier class which will act as a base class or an abstract base class, and we'll derive child classes which will implement this notification, SMS notification, Facebook notification, and Slack notification. And now if I want to have these sort of combinations, then the next natural approach would be to combine these classes and to form a new derived channel or to a new derived class, right? For example, I can say that Facebook plus Slack would be a new class which will have the combinational code of both Facebook and Slack. So basically we're trying to put together all these classes into specialized classes or specialized derived classes or subclasses so that they can serve a need. But as I said, this is a combinatorial issue now because you can have n factorial combinations, and therefore it's not feasible as well as advisable that you have n factorial subclasses. So what's the goal? How can we solve this problem? Now this problem can definitely be solved using the design pattern which we are going to discuss today, right? So this is one use case where you can see that a decorated design pattern will come into picture and will help you to solve this kind of messy issue. Okay. There is another scenario where decorated pattern pops up, and that is, let's say your class is not inheritable. For example, many languages like C++ and Java have a keyword called as final, and which prevents the class from getting inherited, right? So now you, once you declare a class as final, you cannot no more instantiate, or sorry, you can no more inherit it. Now this brings a problem. Now what if I want to modify the object in certain manner, right? I want to have some additional flexibility over those objects which are declared final. Now to sum up this, I can say that there are two scenarios in which decorator design pattern comes into picture. One is that when we have mix and match of objects, when we want to have specialized properties or specialized behavior for those objects which we can generate by clubbing multiple objects together, right? That's one scenario. The second scenario would be that when we are not allowed to modify the existing behavior or properties of an object because they have been declared final, in such scenarios, also decorator pattern comes into picture, right? Now let me give another example, real world example, just to cement this idea that when a decorator pattern is so helpful. Now let's say you are also building a pizza delivery system, right? Where you want to do billing for a pizza company, right? So now if you can recollect, if you have ordered anytime pizza, you see that there is always a base pizza over which you add a lot of toppings. Basically, you can customize your pizza, right? Now the problem here is we have a base pizza which has its own properties, it has its own price rate and all, and then when users customize it, let's say adding extra burst of cheese or changing the pizza toppings, right, or changing the pizza base itself, this creates a lot of combinations, right? So you have a base pizza over which you do a lot of customization, which is very similar. Now this problem is very similar to this notification problem, right, which you see on the screen here. It's similar, very similar to this, that you can have multiple combinations again. Now if every topping is in its own self an object, then combining these objects together and having a and expecting a behavior out of them is again a very tedious task, right? Again, it's a computational problem because again it will explode. So I think now you would have understood when this decorator pattern can come into picture, right? Now let's come to the second question to this problem, that is, what is this decorator pattern, right? Now, just like the previous two design patterns which I have taught in my playlist, which is the strategy design pattern and the state design pattern, a decorator design pattern is also a structural design pattern. Now, a structural design pattern is essentially patterns which deal with the structure of these objects, right? They essentially deal with how these objects are interacting with each other, right? So that's the whole focus of this decorator design pattern, that it basically tries to minimize this friction between two objects talking to each other. Okay, so that's why it's a structural design pattern. Now before getting into the implementation, I also want to give you a small visual understanding how a decorator pattern might look like. Okay, so if you remember a data structure called as linked list, a decorator pattern can be even thought of as a linked list, right? Wherein what you have here is essentially that one object would be pointing to another object, right? And just to demonstrate this, so I have one object here, right? This object would be pointing to another object. This object would be pointing to another object, right? So let me just make it more clear. Something like this, right? So this is object 1, this is object 2, this is object 3, and this is object 4. This is one way of representing this decorator design pattern. Usually if you refer online articles, you'll see that the way they represent this decorator design pattern is by basically wrapping one object over the other, right? So a more popular way of representing the same thing is having multiple objects getting wrapped inside one another, right? So this is like this. So you have this object 1 which is wrapped inside another object called as object 2, which is again wrapped inside another object called as object 3, right? So you can take any of these diagram. I'll try to explain. Basically both the diagrams are same, right? It's the way we see these things, right? Essentially what happens here is the object 1 has a reference to object 2, object 2 has a reference to object 3, object 3 has a reference to object 4, and so on and so forth, right? So this way we can basically chain multiple objects together, or I can also say that this way we can also wrap one object within the other object, right? So I can say that object 3 essentially refers to object 2 and object 2 refers to object 1. Okay, so it's the same one and the same thing. Okay, but the important thing to understand here is that this is the diagrammatic or visual way of understanding decorator design pattern. Okay, so one thing that you have to understand here is every object or every class would have a reference to another object. To make one object to point to another object, we have to make sure that all these objects are of same type. Then only one object can refer to the other object, right? So now for this, we will take the help of interface, right? So interface is something which is going to be a common functionality, and every object or every class would be implementing the same interface so that they'll all have a common functionalities, right? They are all adhering to the common contract now. And this way we'll be able to point from one function or from one object to another object. Okay. All right. Now, before getting into the code, I just wanted to mention one more thing regarding this decorator design pattern, and that is to understand how one object is wrapped within another object. And when I'm wrapping one object within the other object, what do I exactly mean by this? Now, so if I have one object here, let's say this is my object 1, and now this object 1 has certain properties, right? It would have certain set of methods, it will have certain set of properties. Now, I cannot modify this object anyhow. So what I'll do is I'll add certain set of new functionalities on top of this object, right? So let's say I go and create another object and I wrap this object 1 within this object 2. So this is my object 2. Now this object 2 will have some new set of properties and new set of functionalities. Now those new set of functionalities, let's say I call it as NF, new functionality. Now this new functionality is basically wrapping this object 1. Okay, so I'm not disturbing the properties or the functionalities of object 1, but I'm basically adding new set of functionalities in object 2. Now object 2 can definitely make use of this object 1 properties, right? Similarly, I can also have another set of object which would basically be wrapping this object 2. So this is object 3 which is wrapping object 2 now. Okay, I'll give you another example here just to demonstrate this thing very nicely. Programming languages like Java or even in Go, there are multiple methods to read from a file. Now the basic operation here is to read data as a stream of bytes. But then if you are coming from Java, you would have known that there is something also called as buffer reading, right? Basically, which is a wrapper to the basic functionality. And now this buffered reading is basically adding some additional properties or additional functionalities over the raw reading, right? So here we are basically buffering the inputs just to optimize for the block transfers. Then apart from this, you can also have some sort of decompression happening, because mostly when the data is stored on the disk, they are compressed in format. So when you're reading back them into the main memory, you are decompressing on the fly again, right? So I can say that I have a basic reader. Let me just write it here. So I have a basic reader over here. Now on top of this basic reader, let me change my color. On top of this basic reader, I have something called as buffered reader. So this is a buffered reader, which is essentially a bit more optimized because it can buffer the values. So this is another object which is wrapping over this basic reader. Now on top of this, I can have another set of reader which would be decompressing it. So let's say I do a decompression, right? So this is another function or another object which does a decompression. Now mind that this decompression object relies on the output returned by this buffered reader, right? Because this decompression is just a variation, okay, which requires some input from the buffered reader side. Similarly, this buffered reader depends on this basic reader, okay? So whatever output is returned by this basic reader is taken by this buffered reader. It does some processing on top of it, and it returns a value which is taken as an input by the decompression object, and it does the decompression, and then it basically puts it into the main memory, right? And you can extend the stack, right? So after decompression, you have another, you can say decryption, for example. So you can add a decryption layer also. So if you see here, we are basically stacking up all these objects one after the other, right? And just like a stack, the one which is added at the top is going to be called first, okay? So this diagram is also very helpful. If you imagine this wrapping of objects as a stack, it becomes easy to understand how the execution flow happens, okay? So the execution flow is always from top to bottom. Okay, since decompression layer is the first layer or the first object in the stack, this is the one which is going to be called first, then followed by the buffered reader, and then followed by the basic reader. Okay, so the execution call will be from top to down, but the values will be returned from bottom to up. Okay, this is where the values will return, and in the end basically this will be doing the final operations and you will be having the final output. Okay, now if you see this stack combination, you'll also observe that instead of having this stack, I can have my own combinations here. Again, now let's say I don't want to have a decompression, so I can have a combination where I only have a buffered reader and a basic reader. Or let's say my requirement says that I don't want to even have a buffered reader, I just want to read streams of bytes, so I can only directly use this basic reader itself. I don't even need to have these two, right? Or let's say I have another combination where I'm reading this stream of bytes, and then let's say I'm doing them UTF-8 encoding. Okay, so instead of having this stack, I can have something like this. I have a basic reader, right? So this is my basic reader object which I instantiate, and then I pass this object reference into another class or another object called as the UTF-8 encoding, right? So this is another object which is wrapping over this basic reader. So whatever value is given by this basic reader as a output is taken care by this UTF-8 for decoding it, right? So I call this as UTF-8 encoding and decoding layer, right? So this is where you'll find this as an example. This is the real-time example which you'll see, right? So you can see here, I can put all these objects together in whichever way I want to have them, right? So this basically gives you the flexibility to mix and match these objects as per your requirements. Okay, so I think using this example you are clear how a decorator pattern solves both the problems which we encountered earlier, right? One was the combinatorial issue, where if we start to draw the derived classes, we'll have n factorial combinations, wherein here we can just stack them together and we can put them together the way we want to have them, right? And similarly, for the second problem, which was we cannot inherit final classes, this again solves that problem because here we are not touching the original object. So only on top of the original object we are adding a new functionalities. So therefore, this is solving the second issue also. So now let's get into the code and see some more coding examples how we can implement this decorator pattern. So here we are going to see a code example for the problem which we saw earlier, right, which was reading from a disk, right? So now what I have done here is essentially I have created a file reader interface, okay, which will have a read functionality, and this is going to return a stream of bytes to me, okay. And now I have a raw reader, which is basically a class which is responsible for reading raw streams of bytes, okay. Now if you observe carefully, I have a next reference variable which is of type file reader, which is the interface type, okay. Now this ensures that my objects of raw reader class can point to other objects of same interface type, okay. So this is like a reference, just like if you have done linked list, this is just like pointing to the next node, okay. All right, and here is an implementation. So I have just kept the implementation very simple so that you get the crux of what a decorator pattern is trying to solve rather than getting into the complexity of the code itself, right? So this read functionality is essentially returning me a byte stream of characters. All right, so this is one implementation or one class, right? Now similarly I also have a string reader. Now let's say my requirement is that I also want to have a string reader which essentially read not in bytes but gives me a string representation of the data which is stored on the disk, right? So now this class has again a pointer or a reference variable to a file reader interface type, and this is also doing a read operation, okay. And this is the code for implementation. Now if you look at this code, this is the if condition which basically checks whether do I have a next pointer not nil. What it essentially means is if this string reader is wrapping over this raw reader, okay. Just to illustrate this, let's say I have my raw reader here. So I have a raw reader object. Now whatever this raw reader is reading, which is going to be a slice of bytes, this will be passed as a output and which will be read as an input by this string reader, So this string reader object is essentially sitting on top. So this is my string reader. Okay. Now if you look at this, the string reader is not expecting any input, but it is basically going to check whether the next is not nil or not. Okay. So if next is not nil, that means we have a raw reader as a object which is built inside this string reader. Then I will essentially go and read the values. So if you see here sr.next.read, this read is basically invoking this read, this one. Okay, we are basically invoking this read function, and this will return us a slice of or a stream of byte. Okay, so once I have a slice of bytes over here, what I'll do is on top of this I will essentially change it to a string type. Okay, and that this is what I'll return in the end. Okay, so here I'm not returning it, I'm just doing some sort of printing here itself, but this is the whole idea. So whatever output is returned by the inner object is basically taken as an input, and it is processed by the string reader here. So now the string reader converts this into a new type called as the string type, right? So it will give you ABC. This is the string representation of this slice of byte. Okay, this is what I'm doing here. Now let's go to the main function here. So if you see here, I'm creating a raw reader object, and I'm assigning a name to this, and I'm saying it as the next part is nil here. Okay, you can imagine this as the last node in the linked list. Okay, so just try to map these two things, right? A decorator pattern can be mapped in a visual representation to a linked list. Okay, so I have RR, which is the raw reader, and now this raw reader is reading the file, and I'm printing it on the screen. So if I just run this raw reader, now if you see here in this piece of code, I'm just exactly, so here I'm calling the raw reader directly, right? I'm not calling any wrapper class right now, I'm just calling the raw reader itself. So if I do ls, if I run this example now, you see that I'm reading the slice of bytes. Okay, fine. Now let's say I call the new one. Now if you see here, I'm calling this string reader. I'm initializing a string reader object, and inside this string reader I'm passing an object reference of this raw reader. So instead of just reinitializing it, I'm just calling with the RR itself because I've already initialized here in line number 40. So I'm basically passing RR reference in the string reader. Now if I try to read this, what will happen? Let's see again. You'll see that I am getting the raw string, but I'm also getting the string representation. Okay, the stringified version of the raw bytes. So you see that the string reader is basically working on top of the raw reader, right? So I hope you got the idea how a decorator pattern is working under the hood, right? It's very simple that one object basically has a reference to another object. That's it. That's the simplest way to understand this thing. Okay. Now, this decorator pattern design, like whatever code I showed you, right? This is more or less comes from an object-oriented design paradigm. Okay. But languages like Go, and now I think most of the languages have started incorporating the functional paradigm also. The same decorative design pattern can be implemented using a functional approach or a functional paradigm. Okay, so this piece of code which I showed here, which is where one class is referring to another class object, this is more of like an OOP way of doing it. Okay, so let's see the second example where we'll see how we can do the same thing using a functional approach. So now this is example 2, and in this example 2 we are basically trying to understand how we can use this functional approach to solve the same problem. Okay, now here I have taken another example, okay, just to illustrate that how we can put together different pieces of objects or different objects together and we can form a wrapper, right? Okay, for now just forget about the line number 10, just focus on here. This is a function which is like add one. Okay, so this function basically takes a number and just adds 1 to this. Similarly, I have a function called as double, which again adds, or sorry, it multiplies it with 2. Okay, so it doubles the number. And I have a number, I have a function called as subtract 1, which is essentially subtracts 1 from the function or the number. So we have these three functions here. Okay, now if you look at this, programming languages which have functions as their first parameters, or all right. So now if you look at this, this is nothing but essentially a variable which is of type func, which takes an integer and returns an integer. Now, if you are not familiar with functional paradigms, this might be a little confusing and tricky, but programming languages which have functions as their first class citizens, I mean, they support functions equally well, they do have this kind of options, wherein just like we have a normal variable, right, we say int a equal to 10, or normally we say that var a equal to string type. Similarly, I can say that this is a type called as operation func, I've given it, and the type of this variable is this. Okay, basically it's a function signature which I've passed. Now, the reason for doing this is to have again sort of uniformity, right? Because you know that for one object to point to another object, it should, both the objects should inherit from the same interface, right? Now here I'm not having any class or an object. Therefore, to maintain or to get that uniformity, I need to have some way that all my functions are similar in nature, right? For that, I have created a function variable which is of type func int and returns an int. And if you observe, all these three functions, add one, double, and subtract one, they're also having the same signature, right? They are all similar in the signature format, which is same as this. So in a way, you can say that it's a loose way of saying that the operation func is kind of an interface, and all the three functions are inheriting from there. Okay, technically it's not correct, but that's how you can map them in your mind for now. Now let's look at this function here. Okay, so far we have understood what these functions are doing. Okay, now this is the most important part. Here in this function, essentially what we're doing is we're doing this wrapping up. Okay, so here we're essentially putting one object inside another object. Okay, so essentially if you look at this object, I have named it as decorator. This function essentially takes two functions, inner and outer function. Okay, both are of type operation func. Okay, so they have to match the signature, or I can also say that both the functions have to be of same signature type. Okay, see, it's very similar to the previous examples where the object needs to implement this common interface for them to be compatible with each other, right? Similarly, when we want to wrap one function inside another function, they also have to have this similar or exactly the same signature. That's the reason both the functions are taking the same signature, which is operation func, and then in the end they are also returning the same signature out as the operation func. Okay, now what it does is it essentially returns a function back to us. Now if you look at this function, this is the function signature which is same as the operation func. Okay, and now inside this, what I'm doing here is I'm basically wrapping these two together. So I'm saying that whatever num or whatever is the parameter which I'm getting here, that would be first processed by inner function, and then whatever output this inner function generates will be taken by the outer function, and whatever result it generates, that would be returned back to the caller. Okay, so the execution order is always from right to left. Okay, so the innermost function always executes first, then the outer one, and so on and so forth, right? But the function call is always from left to right. Okay, because that's how a stack works, right? You can imagine a stack, right? The outer function is always on the top, then you have the inner function, and then you have the final parameters. Okay, so this is how you are going to arrange your decorators or the functions. You're going to stack them together. Okay, so now let's see. I'll call this decorator function, and I'll pass it a base operation. Now base operation would be the starting operation because I need to have a starting point, right? So let's say add one, which is the name of my function. I'm passing as a base operation here, and on top of this base operation add one, I'm passing a double. So when I call this decorator function, it essentially takes these two operations and then it joins them together in a wrapped fashion. Okay, so essentially what happens is when I make a call here, essentially, so now when I make a call from decorator to this function, what it does is, so add one comes as the first parameter, the second parameter is my double. Okay, now here if you see the outer is double, right? So I'm essentially doing is I'm taking the add one function which will take the num, and on top of this I'm basically saying that okay, whatever is this function, on top of this I'll double of what, double of whatever is returned by this add-on function. So return value will be taken by this double. okay, as an input, and this will basically return an value, right? So this is how we have wrapped these two functions together. Okay, now, and if you look at this, I'm calling decorated operation 5. All right, so I'm making a call now. I'm making the final call here. Now when I make a final call, what would be the expected output here? If you see here, 5 is passed as the parameter. So if I see here, 5 goes here, right? Add 1 basically makes this 5 as a 6 value. So 6 gets passed here. Now when I double this 6, I should get 12, right? So this should be my expected output. Let's run and see this code. So if you see here, the final result is 12. And it also says the order in which they are called. So first add 1 is called and then the double is called. Okay. All right. Now this is how you basically wrap one object within another or one function within the other. Okay. Now this can still be optimized in a certain way that let's say I have multiple functions, right? Here we have only had 2, so we were able to do this using this function decorator. But let's say I have 10. I have 10 functions and I need to wrap them together in certain orders, or depending on my use cases, I want to wrap them together one after the other. What I can do for that? For that, what I can do is I can simply create another function which would essentially call this decorator function internally again and again by passing a list of all the functions which I want to put them or I want to stack them together, right? All right. So I have a code here now called as apply decorators. Okay. Now this function essentially calls this decorator function internally. Okay. So it takes a base function. Again, if you see here, the parameters are again operation func itself, right? Again, it's very similar to the previous one. We have operation func here, and now we are taking validate function as a parameter. Okay. Now again we have a base function over here, and now I'm running a for loop here. So now this is a slice of all the parameters I want to have, or this is a slice of all the functions which I want to stack them, right? So in order to stack them together, I will run a for loop now, and where I'll be passing my base, which will be the first time I'll be passing it, and then I'll be passing the decorator which I'm getting it. So let's say this is a slice. For those who don't know, this is a validate function. Basically, it means it can take 0 or more number of inputs. It's similar to a slice. So what it does is essentially it takes the first decorator or the first function, it wraps the base into it, okay, because this decorator essentially calls this function only. Okay, so we are getting this wrapping up here. Now once you wrap these two together, you store it back into the base. Okay, so just to illustrate this, let's say I pass 3 functions here, a, b and c. Okay, and let's say my base is the base function itself. So now what I'm doing essentially here is I'm looping over the decorators and I'm taking one by one all these functions. Okay, so for the first time I'm passing my base and my decorator is a here. Okay, so when it goes to this function, what I'm doing here is I'm basically saying the outer function is a, so I'm saying a, the inner function is the base itself, so I say base, and the num itself is here. Okay, so let me just clear the screen. So this is what I'm doing here, and this is what is being returned by this decorator function. So now this base is containing this thing, this as the new base value. Now again when I run this loop, I see that I get a new decorator which is decorator b. I get this new decorator called as b. So what I do is, now my base is essentially this, it is a base of num, and then my decorator here is now b. So now this goes as an input parameter here. All right, and now what it does is it again wraps them together. So which is outer function? The outer function is b and this is the inner function. Therefore this would wrap b outside, then a, and then you have your base of num like this. So this is what is returned by this function here. Okay, so now once you return this function, again in the next loop you get c as an output. So now again when this c goes here, what you do is essentially wrap c on top of this, and this is what is returned in the end after you iterate over entire slice. Okay, so this is the wrapped up objects or wrapped up functions which you get in the end. Okay, now when you call this, you know, right, this is the function execution order or function call order. Okay, the first c will be called, then b, and then a, and then the base. So the base would process first, then it will return the answer to a, answer would A would do some sort of again extra or additional processing. It will return to B, and then B would return the answer to C. C would again do the final set of operations, and then it will return back to the caller. Okay, so this is how you get the final output. All right, now if you look at here, I've basically commented on my previous code, but now we'll use only the apply decorators. And apply decorators, what is the benefit which I get? Now here I can pass all my different functions as a comma separated values, right? So I can pass add one, then followed by double, then subtract one, right? And all this will be applied the way I've explained you, right? They will apply, and finally you'll get this decorator operation. Now when you call this decorator operation with 5, you'll get an answer. Okay, so if I run this code again, you see that first add one is called, then double, then subtract one, and then you get the final answer as 11. Okay, so this is how you basically achieve this wrapping of objects. All right, now this second approach, right, which I've talked right now, is far more common to see in production codes, because Go has this very beautiful integration of functional programming paradigm, right? So Go does support functional programming paradigm. Therefore, you will see a lot of production code written in this way. Okay, so instead of having classes and objects, you can directly club functions together to achieve the same functionality. Okay, now let's see the third example, wherein I'll try to show you a real world example of writing middlewares. Right now, if you are familiar with writing middlewares, you would have guessed by now that middlewares are one of the, again, very classic examples where you find these decorator patterns being used again and again. Okay, so again, now this third example is an extension to the second example. Now in second example, we used very simple and very easy functions. We club them together. Here the same idea is extended, but with a more realistic example. So for example, if you are not familiar what a middleware is, essentially it's nothing but it's a bunch of functions which you want to get executed before your handler gets executed, right? So for example, let's say you want to log for every incoming request, you want to log those requests in some log format, right? So you can have a logging middleware. Now similarly, let's say you also want some of your API to be authenticated, so you can also have an authentication middleware here. Okay, and then you'll have a final handler which will eventually give you the final result. I have kept it very simple here. I have just made it hello world, right? And just like the previous example, I again have a apply middleware function which essentially takes the handler, which is the base handler, and it takes a bunch of middlewares, right? And this is of type middleware. Now if you look at middleware, this is very similar to the previous example. In the previous example, I had something called as operation func, which was of type this, right? This was the signature type. Similarly, I have a middleware which is of this signature type. Okay, so basically this function essentially takes in a handler func. This itself is a interface. Okay, it's an interface type, and similarly, I should not call this as an interface. It's essentially an adapter. I'll talk about this in some other video in detail, but basically this is the signature it expects all the handlers to be in, and it returns the same thing back also. Okay, so if you see here, my logging middleware is of the similar, is exactly the same type as of this middleware type. Okay, similarly my authentication middleware and as well as my handler. Okay, sorry, not my handler. Handler is something separate. That is the base function which I want to execute. And now what I can do here is, if you get in the main function, which is also going to be the client code for this route, I'm applying these middlewares. So this is my base, and then I'm passing two other middlewares, which is logging middleware and authentication middleware. And now if you have understood the second example, this is again the same thing. If you look at here, again I'm iterating over the middleware, and I'm again mapping them together. I'm basically fusing them together. So logging middleware and authentication middleware are basically wrapped inside one another, right? And at the core we have the handler. Okay, so again if I run this code, you see that I have started my server. So let's make a call to this. So if I make a call to here, right, I get hello world as my output, right? This was as expected. But if I come back to server, you see that I've added authentication layer. So it says user has been authenticated, and it also says that it's logging the request type. Okay, so it has logged both of them. Okay, again, this gives a lot of flexibility to us. For example, there might be certain APIs which do not want authentication, right? So for such routes, you can simply ignore this. You can simply remove this authentication part here. You only want logging, so you just keep logging as a middleware. You remove the authentication part. If you want authentication, you can add an authentication here. Usually this is not the correct format. Authentication is always the first one, so it's always going to be the first layer, and if it succeeds, it goes to the logging layer. If it fails, the authentication layer itself or the authentication middleware itself will return back throwing some error, right? Let's say you also want to encrypt the data, or you want to add some body validation. So again, you can have a body validation middleware, right? Something like this here. And then you can put all your logic in the body validation middleware. So this way you can club multiple functions together and you can get whatever is the desired output, right? Okay, so I hope you have understood what a decorator design pattern is, and through all these examples I would have made it more easier for you to grasp it and to understand it, how this is working out. Okay, I hope you have learned something from this video. If you did, do like this video and subscribe to the channel.